So we're going to go over day 4 to review for the quiz. So example 1 says at a sand and gravel plant, sand is falling into a conveyor and onto a conical pile at a rate of 12 cubic feet per minute. The diameter of the base of the cone is 2 times the height. At what rate is the height of the pile changing when it is 16 feet high? So what shape do we have? A cone. Our formula for a cone, or the volume of a cone, is 1/3 pi r squared h. So it says the pile is changing at a rate of 12 cubic feet per minute. So what would 12 be? Keyword cubic, what does that tell us? dV over dt. The diameter of the base of the cone is 2 times the height. So the diameter of the base is 2 times the height. So we can say diameter is equal to 2h. At what rate is the height of the pile changing when it is 16 feet high? So it's asking us for at what rate is the height changing. So dh over dt is what we have to find when the height is 16 feet. So here we could find our derivative of our equation, but we don't know what dr over dt is. We don't really know what the radius is. We could find the radius, but we don't know the rate of our radius. So we want to change r to be in terms of h. So we can use our little equation here to help us make r in terms of h, because what we're trying to find is dh over dt. And if dr over dt is unknown, we can't just take the derivative right off the bat. So if d is equal to 2h, there's no r in this. How can we relate it to r? Awesome. D is 2 times r, so we could say 2r is equal to 2h. So we divide by 2. So what does r equal? H. So I'm just going to take h and plug that into r. So my new volume equation is going to be 1/3 pi h squared times h. What's h squared times h? H cubed. Now let's take the derivative. So dv over dt is equal to 1/3 pi. What's the derivative of h cubed? Three h to the second dh over dt. Bella.
So you only find the derivative of h?
1/3 pi is our constant, so that just stays out front. So technically here we're just finding the derivative of h. If we knew what dr over dt was and we took the derivative of the whole thing here with the r times the h, we'd have to do the product rule. But since,
Just for r squared and h.
yeah, because 1/3 pi is a constant, so we can just push it out front. So 1/3 times 3 will actually cancel. So dv over dt is pi h squared dh over dt. So let's plug in everything we have. We know that dv over dt, we said was 12, is equal to pi. H is 16, so 16 squared. dh over dt is our unknown. From here, we're going to solve for dh over dt, so we can just divide everything. 16 squared would be 256. So we're going to divide both sides by 256 pi. So dH over dt is equal to 12 over 256 pi. I'll let you guys use a calculator, a scientific calculator for the quiz. So bring a scientific calculator. But just leave your answer in terms of pi. So here we just need to simplify our fraction. So this would be, when we divide the top and the bottom by 4, we should get 3 over 64 pi. Yes? If you had two different variables that you're multiplying, you'd need to do the product rule. Here we just have one variable, which was just h, so we just take the derivative.
Are we gonna go over like the homework a little bit?
I'll answer homework questions too. I want to get through these 3 questions and then I'll do some from the homework if you want to see those worked out. What would our unit be here? Perfect. Feet per minute. Example 2 is kind of similar. It says a conic tank vertex down is 12 feet across the top and 10 feet deep. If the water is flowing into the tank at a rate of 10 cubic feet per minute, find the rate of change of the depth of the water the instant it is 8 feet deep. So what shape are we dealing with here? A cone. So our volume of a cone would be 1/3 pi r squared h. The shape of our cone is 12 feet across the top, so this would actually be our diameter, and 10 feet deep would be the height. If water is flowing into the tank at a rate of 10 cubic feet per minute, find the rate of change in the depth of the water the instant it is 8 feet deep. So 10 cubic feet per minute would be what? dV over dt, perfect. And we're looking for the rate of change of the depth of the water. So dH over dt is what we're looking for. That's what the question's asking. The instant the water's 8 feet deep. So when h is 8. So this question's similar to the last one. It doesn't give us dr over dt, even though our radius is changing. So we need to put r in terms of h. So we're going to use these 2 pieces of information, the fact that d is equal to 12 and h is equal to 10, to help us replace r in terms of h. So we're going to set up a proportion with what we have for r and h. If d is equal to 12, what is r equal to? 6. Perfect. So I could say r over h is equal to 6 over 10. We can cross multiply. So 10r is equal to 6h. We're trying to figure out what r equals, so I can divide both sides by 10. So r is equal to, simplify our fraction here, 3 over 5h. So we're going to replace r with 3 over 5h. So our new volume equation is going to be 1/3 pi times 3 over 5h squared times h. All right, let's simplify our new formula that we have here. When we square this, we want to make sure we square the fraction and square h. So this would be 9 over 25h squared. We can simplify it a little bit more. 3 goes into 9 3 times. So this would be 3 over 25 pi times h cubed. Now let's take the derivative. dv over dt is equal to, our constant's just going to stay, we'll leave it out front, so 3 over 25 pi. Then we just take the derivative of h cubed. So our derivative would be 3h to the second power. What are we missing? dh over dt. So dv over dt is equal to 9 pi over 25 h squared dh over dt. Now let's plug in everything we have. So dv over dt was 10, is equal to 9 pi over 25. H is 8, so this would be 8 squared. dh over dt is what we're looking for. From here, just be careful with the math. 8 squared would be 64, times 9 would be 576. We can multiply both sides by 25 to get it to cancel. So 250 is equal to 576 pi dh over dt. And then divide by 576 pi. So dh over dt is equal to 250 over 576 pi. We can simplify this. I think we can just divide it by 2. So 125 over 288 pi. What would our unit be here? What's our unit? So this is just how the height's changing, so it'd just be feet per minute. If it was talking about how the volume of the water is changing, then it would be cubed. Here. So it would cancel out with the denominator. So we just multiplied by the reciprocal since we had to divide to get it to the other side. All right, let's do example 3. A 20-foot ladder is leaning against the vertical wall. The bottom of the ladder is being pulled horizontally away from the wall at a constant rate of 4 feet per second. How fast is the top of the ladder moving and in what direction when the bottom of the ladder is 14 feet from the wall? So we've done a question almost exactly like this one. Let's draw our picture. So I have a wall, the ground, and my ladder. The ladder is 20 feet. We can plug 20 in. We don't have to use a variable here because this is not changing. So if you have something that does not change, it stays the same. The length of the ladder doesn't change. You can just plug that number in. So 20-foot ladder is leaning against the wall. The bottom of the ladder is being pulled horizontally away from the wall. So I'll call the bottom X and the wall will be Y. So the bottom of the ladder is being pulled against the wall at a constant rate of 4 feet per second. So the base is changing, so dx over dt would be 4. How fast is the top of the ladder moving and in what direction when the bottom of the ladder is 14 feet from the wall? So when x is 14, we need to figure out what y is, and it's asking us how fast it's moving down the wall, so we're looking for dy over dt. How can we find what y is? Pythagorean theorem. So when x is 14, when our ladder is 14 feet from the base of the wall, we want to figure out how high it is on the wall. So y squared plus 14 is equal to 20 squared, 14 squared. So y squared is equal to 190 plus 196 is equal to 400. Subtract both sides by 196. So y squared is equal to 204. Take the square root. So y is the square root of 204. We can simplify this, but you don't have to because this isn't the answer to our question. So if you want to just leave it like this, that's fine. You don't need to simplify because the rest is just going to be our work. So it's asking how fast is the top of the ladder moving and in what direction. So we're looking for dy over dt. What would the equation that we need to set up be? Awesome, Pythagorean theorem. So y squared plus x squared equals 20 squared. Now I can plug 20 into my Pythagorean theorem because the length of the ladder does not change. But what is changing is our y and our x. It's because we have a dy over dt, or we're looking for dy over dt, we have a dx over dt. Those are changing. So I need to leave those as variables in my equation, and I'm going to take the derivative of this. So the derivative of y squared would be 2y dy over dt. The derivative of x squared would be 2x dx over dt. What's the derivative of 400? 0. Perfect. So now let's plug in everything we have. So 2 times y is square root of 204 dy over dt, plus 2 times x is 14, dx over dt is 4, is equal to 0. So 2 times the square root of 204 dy over dt plus, this would be 112, is equal to 0. We're solving for dy over dt, so let's just move everything to the other side. Subtract 112. And divide by 2 times square root of 204. So dy over dt is equal to negative 112 over 2 times the square root of 204. We can put that in the calculator. We'll get negative 3.9. But when we're talking about the speed, it's asking us how fast is the top of the ladder moving. Can speed be negative? No, so it'd be positive 3.9. 3.9 what? Feet per second. Perfect. And in what direction is our ladder moving? It's moving down. Since our answer was negative, this tells us that it's moving down. All right, so for number 2, we want to find the derivative with respect to time. So since x and y are being multiplied to each other, we have to do the product rule. So the first times the derivative of the second plus the second times the derivative of the first. So our first would be x times the derivative of the second. What's the derivative of y? dy over dt. Plus the second, which is y, times the derivative of the first. What's the derivative of x? dx over dt. Is equal to, what's the derivative of 8? 0. So it says, find dy over dt given that x is 2 and dy over dt is, or dx over dt is 10. So x is 2, dy over dt, plus y we don't know, dx over dt is 10. Is there a way that we can find y? So we need to figure out what y is because the question's asking us for dy over dt, so we can't have two unknowns. How would we find y? Awesome. We're going to plug it into our equation here. So 2 times y equals 8, divide by 2, y equals 4. So it doesn't explicitly give us y, but we are able to find it with the equation that's given. From here, we just solve for dy over dt. So 2 dy over dt is equal to negative 40, and then divide by 2. So dy over dt is equal to negative 20. So the formula for the volume of a cone is given below. Find the rate of change of the volume for each of the radii given below if dr over dt is 6 inches per minute and h is equal to 15r. So here it gives us dr over dt. It doesn't tell us dh over dt, so we want to change h to be in terms of r. So we can do that because it gives us h is equal to 15r. So I can just plug that into my h. So our new volume equation would be 1/3 pi r squared times 15r. We can clean this up a bit. 15 times 3, or 1/3 would be 5. So 5 pi, and then r squared times r would be r cubed. So now let's take the derivative. dv over dt is equal to 5 pi is our coefficient, so we can just leave that out front. What's the derivative of r cubed? 3r squared. What are we missing? dr over dt. So our dv over dt is equal to 15 pi r squared dr over dt. So dr over dt is 6 and r is 8. So let's plug in. So 15 pi r squared would be 8 squared. dr over dt is 6. I don't have my calculator on me, but 8 squared is 64 times 15 times 6, I'm going to assume is 5,760 if we did it right. But it should be. What would our units be here? Don't look at what was sign. What would our unit be? If this is the rate of change of the volume. Awesome. Inches cubed per minute. So since it's how the volume changes, it has to be cubed. If you're talking about how the area changes, it's going to be squared. If you're talking about how the volume, it's cubed. If you're just talking about the radius or the height or the length of something, it would be just normal. So at a sand and gravel plant, sand is falling off a conveyor into a conical pile at a rate of 8 cubic feet per minute. The diameter of the base of the cone is approximately 3 times the altitude. At what rate is the height of the pile changing when the pile is 22 feet high? So our shape is a cone. Our volume of the cone is 1/3 pi r squared h. Sand is falling off the conveyor onto the conical pile at a rate of 8 cubic feet per minute. So what would 8 be? Perfect. dV over dt. One of our clues is that it said cubic. So it's talking about how the volume changes. The diameter of the base of the cone is approximately 3 times the height. So D is equal to 3. It says altitude, but altitude is the height. So D is equal to 3 times H. At what rate is the height of the pile changing when the pile is 22 feet high? So it's asking us for the change in the height, dH over dt, when the height is 22. So we don't know what R is. We could find it, but we don't know the change in R. We don't know dr over dt. So let's change R to be in terms of H. So we're going to use the equation that it gives us here to put R in terms of H. How do we make D in terms of R? Because it says the diameter. But how do we come up with the radius from the diameter? D is 2R. So I'm just going to replace D with 2R. So 2R is equal to 3H. I want to get R all by itself, so I'm going to divide both sides by 2. So R is equal to 3 over 2H. So let's plug that in. Our volume is 1/3 pi 3 over 2H squared times H. We can simplify this. So we have 1/3 pi. We have to square 3/2 and square the H. When you square 3/2, don't forget to square the top and the bottom. So this would be 9 over 4 H squared times H. 3 goes into 9 3 times. So our volume would be 3 over 4 pi H cubed. Now from here, let's take the derivative. dV over dt is equal to, we can just leave our coefficient out front, 3/4 pi. And let's take the derivative of h cubed. What's the derivative of h cubed? 3h squared dh over dt. So dV over dt is equal to 9 over 4 pi h squared dh over dt. Now let's plug everything in. dV over dt we said was 8. 9 over 4 pi. H is 22, so 22 squared. dH over dt is what we're looking for, so that's going to stay. From here, just put in your calculator. 22 squared times 9. I don't have my calculator. So we're going to trust WebAssign. Say that our answer is 8 over 1089 pi. What would our unit be here? We're talking about at what rate the height is changing. Feet per minute. Perfect. A boat's being pulled into a dock by means of which a 12 feet above, by means of a winch, 12 feet above the deck of the boat. Okay, that makes more sense. A winch pulls the rope at a rate of 4 feet per second. Determine the speed of the boat when there's 13 feet of rope out. The height of the deck doesn't change. So that's 12. 12 is going to stay the height of the deck. But what is changing is the distance from the boat to the deck and the length of the rope. So I'll call the distance at the bottom x. So we have 12 squared plus x squared is equal to y squared, because y is our hypotenuse. We're given that the winch pulls in a rope at a rate of 4 feet per second. So the rope's going in at 4 feet per second. So our rope is y, so that would be dy over dt is 4. Determine the speed of the boat when there is 13 feet of rope out. So y is equal to 13. We're looking for how fast the boat is going towards the dock, so that would be dx over dt. So first, let's find the distance from the boat to the dock. Let's find x when y is 13. So we'll have to do Pythagorean theorem. 12 squared plus x squared is equal to 13 squared. 12 squared would be 144, plus x squared is equal to 169. Subtracts 144. So x squared is equal to 25. So x would be 5. So let's take our derivative and then plug everything in. What's the derivative of 12 squared? 0. Perfect. You can leave it as 12 squared or 144. It doesn't matter because your derivative is 0. What's the derivative of x squared? 2x dx over dt is equal to, what's the derivative of y squared? 2y dy over dt. Perfect. Let's plug in everything we have. So x is 5, 2 times 5. Dx over dt is our unknown, that's what we're looking for, is equal to 2 times y, which is 13, times dy over dt, which is 4. So 2 times 13 would be 26, times 4 would be 104. And 2 times 5 is 10, so 10 dx over dt is equal to 104, and then divide by 10. So dx over dt is equal to 10.4. 10.4 what? Feet per second, perfect.